Welcome back to OwlsPrep. This is part 2 of topic 1.5. Part 1 was entirely about the zeros of a polynomial. This one covers the two things in this topic that have nothing to do with zeros at all. First, someone hands you a table of values. No formula. Can you still work out the degree? Second, how do you tell whether a function is even or odd? Both of them come straight out of things you have already seen, so let's go. Here's a different kind of question. Everything so far started from a formula. But suppose someone just hands you a table of values, no formula at all, and asks what degree the polynomial is. You can still find it, using nothing but subtraction. Take the outputs, 1, 2, 9, 28, 65. Subtract each one from the value after it. 2 minus 1 is 1. 9 minus 2 is 7. 28 minus 9 is 19. 65 minus 28 is 37. That new row, 1, 7, 19, 37, is called the first differences. Now do exactly the same to that row. 7 minus 1 is 6. 19 minus 7 is 12. 37 minus 19 is 18. Those are the second differences. One more round. 12 minus 6 is 6, and 18 minus 12 is 6. Constant at last. Now, why should any of that work? Not just as a rule to remember. You can watch it happen. Take a general quadratic. F of x equals ax squared plus bx plus c, and subtract two neighboring values. The ax squared term appears in both, so it cancels exactly, and what survives is 2ax plus a plus b, a linear expression. Degree 2 went in, degree 1 came out. The highest power always cancels like that, at every degree, which is why one round of subtracting drops the degree by exactly 1. You already met the first two cases in topic 1.3 without calling them differences. A linear function had a constant rate of change, and a quadratic's rates formed a linear pattern. So watch the degree fall as you go down the table. Our f is degree 3. The first differences are degree 2, the second difference is degree 1, and the third differences are degree 0. That is, a constant, the 6 row. A constant is the finish line, because a constant is a degree 0 object. And since each round takes the degree down by exactly 1, the number of rounds to reach that constant is the degree you started with. 3 rounds to a constant here, so the degree is 3. One thing to be clear about. This tells you the degree, not the formula. Recovering the actual polynomial is a separate job. And the inputs must be equally spaced, otherwise the differences are not comparable and none of this holds. One more question about a polynomial, and it's the first time this series has asked it. Does its graph have a symmetry? Let's answer it with numbers before any definition. Take g of x equals x to the fourth minus 3x squared, and feed it a pair of opposite inputs. G of 2 is 16 minus 12, which is 4. And g of negative 2 is also 16 minus 12, 4 again. Opposite inputs, identical outputs. Now take h of x equals x cubed minus 3x. That's the same cubic we used back in topic 1.4. H of 2 is 8 minus 6, which is 2. H of negative 2 is negative 8 plus 6, which is negative 2. Opposite inputs, and now the outputs are opposites as well. Those two behaviors are what the names describe. The first one is an even function, f of negative x equals f of x. On the graph, the 2 points sit at exactly the same height, so the curve is a mirror image across the vertical line x equals 0. That's the dashed line down the middle. The second is an odd function, f of negative x equals negative f of x. On the graph, the 2 points are opposite each other through the origin, and notice the origin is the midpoint of the segment joining them. That's what makes it a half-turn. Rotate the whole curve 180 degrees about the origin, and it lands back on itself. One thing to keep straight. This even is about the function, and it is not the same even as the even multiplicity from a moment ago, which counted repeated factors. Same word, different job. Finally, a quick read for a polynomial written as a sum of powers. If every exponent is even, the function is even. If every exponent is odd, it's odd, and a mix is neither. The constant term counts as an even power. So part 2 in one pass. Given a table over equally spaced inputs, difference the outputs repeatedly. Each round drops the degree by 1. So a polynomial of degree n flattens out to a constant after exactly n rounds. That's how you read the degree off a table with no formula in sight. And for symmetry, feed in a pair of opposite inputs. Same output means the function is even. F of negative x equals f of x, a mirror image over the line x equals 0. Opposite output means it's odd. F of negative x equals negative f of x, a half turnabout the origin. If the exponents are all even, it's even, all odd, it's odd, and mixed means neither. Next time, topic 1.6 looks at n behavior, where the leading term takes over. See you there.